Lesson 117. Okay, direct and inverse variation, but we're adding in where one of the variables is squared. Okay, so we did direct and inverse variation, and what'll be on the test will not be this, all right, just the basic ones. So direct variation, what's like the general formula for direct variation? Yep, y equals k times x, but we plug in like the actual variables. And what's the general formula for inverse variation? Exactly. Now we're going to start adding in the word squared. Like it varies directly with something squared, or it varies inversely with something squared. So you just have to read a little more carefully to make sure you have the squared in there. All right, so let's try one. The distance required for an automobile to stop is directly proportional to the square of its velocity. So distance is directly proportional to the square of the velocity. So you're going to start with d equals. It goes in order of the variables, like the sentence goes in order of the math, okay? So distance varies directly is k times, but now it's the square of the velocity, and so I do v squared. That's the only new part, okay? If a car can stop in 200 meters at 20 kilometers per hour, so 200 meters is the distance, okay? And this kilometers per hour is like a speed or a velocity, so 20 gets plugged in for V. All right, they give you 1 point to plug in to find K, right? So they give you that just so you can find K. What's 20 squared, you guys? It is 400, all right? And then we're going to solve for K by dividing both sides by 400. We do get a fraction here, so K is equal to 1/2 when you reduce. Okay, plug it back into the formula. D equals, so the distance equals 1/2 times the velocity squared every time. Now we answer the last part of the question. What will be the required stopping distance? So what is D at 28 kilometers per hour? That's your velocity or your speed. All right, so we'll plug in 28 here. You have to square the 28 first and then multiply by 1/2, and you would get 392 meters. All right. And it's just meters because it's distance, and the units for distance is meters. Okay. The weight of a body on or above the surface of the earth varies inversely with the square of the distance from the body to the center of the earth. So let's write our sentence, the weight, so we'll do W, okay, varies inversely means what? Yep, K divided by. We always use K for our constant every time. All right, K divided by. And again, it says the square of the distance. So be sure you read super carefully so you don't forget the square. Most people just forget it. So read carefully. Okay. D squared. Now it says if a body weighs 10,000 pounds, so there's the weight of the body is 10,000, at a distance of 500 miles from the center of the earth, or 5,000, sorry. 5,000. Okay, so we plug that in. 5,000 squared. I suppose you could evaluate that, or we could just multiply both sides by 5,000 squared to get it out of the denominator here. That's going to be a really big K with a lot of zeros. All right. So we're going to multiply that out. And you should get 2.5, if you want to write it in scientific notation, times 10 to the 10th. All right, so now I know that weight equals 2.5 times 10 to the 10th is your K. And it asks another question. How much would it weigh, meaning the body weigh, 50,000 miles from the center of the earth? So that's the distance. Be careful when you plug in this 50,000, you guys. You do have to square it, okay? And I would probably plug that into my calculator using my exponents and my scientific notation. Okay, when you plug it into your calculator, make sure you either have parentheses there or you do that fraction button that I taught you guys to do for all the unit multipliers, all right? And then you get 100 pounds. for the weight. And again, go back and check your units. So how do I know it was pounds? Because the weight was all in pounds. All right. So we did one direct variation and one inverse variation. So I think we're good to go with a square.